Hello GATE aspirants, welcome to part 6 of GATE Electronics series. Question 25. Which one of the following does not represent an exclusive OR operation for inputs A and B? So let us check for each option. Option 1 is A or B. I can use De Morgan's law here. So this will be A bar or B bar. And then we can use distributive law, and then this will be A bar or B A bar or A B bar or A bar B bar. So this will be 0 and this will also be 0. So from here we can write B A bar or A B bar. This is definition of XOR gate. So this is simply XOR gate, A XOR B. That means A is a XOR gate. For the second one, this is also XOR gate. See, this part is also here. So obviously this will also be XOR gate. So only the fourth option is not correct, because this will give us, for option D, A or B, AB. This will be AAB or BAB, and this will be AB because AA is A, or this will be AB, and A or A is also A. So this will be AB. So this one is not XOR gate. So option D is correct over here. Next question, 27. In the given circuit, the voltage across the source resistor is 1 volt. The drain voltage in voltage. Now this is gate, this is drain, and this one is source. Now current ID will flow in this direction from drain to source, and these resistances are given to us. Now the voltage at source, this voltage will be Vs is equal to voltage drop across this 500 ohm resistor. So this will be equal to ID into Rs. And this voltage is given to us, it is 1 volt. So ID into 500 ohm. That will give us ID, that is drain current. ID will be 1 upon 500, so this will be 2 milliampere. So ID is known. Now let us use Kirchhoff's law in this circuit. So VD, that is drain voltage, this voltage at this point, this will be equal to, let us consider this to be VDD. So this will be VDD minus voltage across this resistor. So that means VDD minus IDRD. Now VDD is given, that is 25 volt, ID is 2 milliampere, and RD, this resistance is 5 kilo ohm. So this will be 25 minus 10, that is 15 volt. So the answer is 15 volt. Next question, 40. The band gap of intrinsic semiconductor Eg is 0.72 electron volt, and mh star is equal to 6 me star, that is mass of hole and mass of electron. Effective masses are given. At 300 Kelvin, the Fermi level with respect to edge of the valence band is at. Now we want to find out EF, Fermi level with respect to valence band. So EF minus EB. This is asked. Up to 3 decimal places, value of KB is given. Now we have EF is equal to EC plus EV by 2 plus 3 by 4 KBT ln of MS star upon ME star. So this is the value of Fermi level, and we want to find EF minus EV. So let us subtract EV from this on both sides. So EF minus EV, that will be equal to, this is EC by 2 plus EV by 2 minus EV plus 3 by 4 kBt, and here it is given that effective mass of hole is 6 times effective mass of Me. So this will be 6 Me star upon Me star. So this will be ln 6. Now this will be EV by 2 minus EV, so that will be half minus 1, that is minus half. So this will be EC minus EV upon 2 plus 3 by 4 kBt into ln 6. EC by EV is Eg, that is band gap energy. So this will be Eg by 2 plus 3 by 4. Value of Kb and T is given to us, so we can substitute it here. So this will be 0.72 electron volt by 2, this is Eg, plus 3 by 4 into kBt. At 300 Kelvin, value of kBt is 26 milli electron volts. So 26 milli electron volt into ln of 6. So this value comes out to be 0.3949 electron volt. So we can round it off to 3 decimal places. This will be 0.395 electron volt. So the answer is 0.395 electron volt. And in the official answer key, the range for this answer was 3.94 to 0.395. Next question. 44. Consider the circuit shown in the figure where RC is equal to 1. For an input signal Vi shown below, choose the correct V0 from the options. Now this circuit is differentiator circuit. So this is a differentiator with RC is equal to 1. Now output voltage V0 is equal to minus RF, that is feedback resistor, Ci, that is input capacitor, dVi by dt. That is expression for output voltage. But since RC is equal to 1, this V0 will be simply minus dVi by dt. Now let us take derivative on both sides. So for this part, here V is directly proportional to T. So I can write Vin is equal to, and since this intercept is at 1, this slope is 1, so I can write Vin is equal to T. That means V0 is equal to minus 1, and when Vin is equal to minus of T, that means V0 will be 1. So the option that is correctly matching it is option B. Next question number 46. In the simple current source shown in the figure, Q1, Q2 are identical transistors with small current gain beta is equal to 100 and VBE is equal to 0.7 volt. Here VCC is given 300 volt. The current I0 is. We want to find out this current. Now let us consider first this path. Now for this path, I can write VCC is equal to ICRC plus VBE. Voltage across 5 kilo ohm resistor plus voltage across VBE. So IC1, that is collector current for this first transistor Q1, this will be VCC minus VBE upon RC. So this will be 30 minus 0.7 upon 5 kilo ohm, and this is equal to 5.86 milliampere. Now we have another transistor Q2 as well. This current is going from this. So this current is IC1 and this current is IC2. this IC2 plus this current IB2 is going into the emitter of Q2, and some part of IC1 is going here. So if I consider this point, then IC2 plus IB2, and if this part is IB1, then I can write by applying KCL, some portion of IC1 is going into the base, so IC1 minus IB1, this will be equal to IC2 plus IB2. And our objective is to find IC2. So IC2 is equal to IC1 minus IB1 minus IB2. And since these two transistors are identical, IB1 will be equal to IB2. So I can write IB1 is equal to IB2 is equal to IB. So this will be IC1 minus 2IB. IC1 is 5.86 milliampere, and relation between IB and IC is a factor of beta only. So I can write 2 into 5.86 milliampere upon 100. 100 is beta. So this will be 5.86 milliampere. 1 minus 2 by 100. So this will be equal to 5.7428 milliampere. And if we round it off to 2 decimal places, then IC2, that is I0, will be equal to 5.74 milliampere. And the range for the answer of this question was given 5.74 to 5.75 in the official answer key. Next question. In the given circuit, if the open loop gain A is equal to 10 raised to 5, the feedback configuration and a closed loop gain are AF, that we have to find out for this case. Now here input is given to non-inverting terminal. So this is a non-inverting amplifier. For which A is equal to, that is open loop gain is equal to 10 raised to 5. Closed loop gain is equal to 1 plus RF upon RI for non-inverting amplifier. So this will be 1 plus RF, that is 9 kilo ohm, and RI is 1 kilo ohm. So this will be 10. And the feedback configuration is series shunt type configuration. So here option C is correct. So these were all the questions from electronics part of GATE 2015 paper. If you like this video, please give it a thumbs up and subscribe to my channel for more videos. Keep learning.